Dear students, welcome to the class. I am Dr. Tirupathi Reddy, Department of Mathematics, B.V. Raju Institute of Technology, Narsapur. In this linear algebra and calculus course, today we are going to see working principle of maxima and minima for a function involving two variables. Let us see the working rule. Working rule to find maxima and minima for function involving two variables x comma y. So, in this, given a function involving two variables f of x comma y. In step 1, we have to compute the partial derivatives dou f by dou x equal to 0 and dou f by dou y equal to 0, and these are called sufficient condition for a function to admit either maximum or minimum. So, compute the partial derivatives and put equal to 0. Therefore, we are going to get two equations. By solving these equations, we are going to get a points of the form in the form of ordered pairs x comma y, which are a1 comma b1. We get when on solving a1 comma b1, a2 comma b2 and so on, an comma bn. We call these points as stationary points. So, therefore, in step 1, when it comes to the maxima minima for a function involving two variables, finding stationary points. Once the stationary points are computed in step 1, we have to compute the higher order partial derivatives, which are denoted with L, which is given by dou square f by dou x square, and m is given by dou square f by dou x dou y, and n is equal to dou square f by dou y square. We have to compute these higher order derivatives L, m, n. And in the next step, we have to consider the one of the stationary point a1 comma b1. Likewise, we are supposed to check the conditions in all possible stationary points, but let us consider the first one a1 comma b1. We have to check the sign of ln minus m square. If it is greater than 0 and L is greater than 0, then f has maximum at a1 comma b1. First stationary point is a1 comma b1. So, at a1 comma b1. Similarly, if ln minus m square is greater than 0 and L is also greater than 0, then we can conclude that f has minimum at the point a1 comma b1. If ln minus m square, the sign of ln minus m square is negative, then we can conclude that function has neither maximum nor minimum. In this case, this point a1 comma b1 is called as saddle point. And the last case is if ln minus m square equal to 0, in this case no conclusion can be drawn about maxima or minima and needs further investigation. This is what we have to conclude in the case of ln minus m square is equal to 0. So, therefore, it is a 3-step process. In step 1, we have to compute the stationary points. In step 2, we have to check the sign of ln minus m square. at each and every stationary point. For instance, at a1, b1, if you compute ln minus m square as greater than 0 and l as less than 0, then f admits maximum at the stationary point a1 comma b1, and if ln minus m square is greater than 0 and l is also greater than 0, f admits minimum at the point a1 comma b1. And if ln minus m square is negative, we can conclude that f of x comma y has neither maximum nor minimum. In this case, this point a1 comma b1 is called as saddle point. And then if ln minus m square is equal to 0, we have to conclude that no conclusion can be drawn about maxima or minima, and it needs further investigation. So this is what the working rule for finding the maxima and minima for a function involving two variables. In the next class, we will see problems related to maxima and minima with constraints as well as without constraints. Thank you for watching.
Like, share and subscribe. Hit the bell icon for more updates.